Assalamu alaikum. My name is Malik Siraj and I am here to continue my previous lecture. We are talking about application layer protocols. We talked about this thing that application layer protocols either uses client server architecture or peer-to-peer architecture. Till now, we talked about many different applications and we have seen that these applications uses client server architecture. In today's class, we are going to explore different applications that uses peer-to-peer architecture. So before going in detail about those applications, first we try to understand what is peer-to-peer architecture. So pure peer-to-peer architecture. In client-server architecture, we talked about this thing that there is a server which is always on and which is listening on some port, and the clients actually connects to the server on that port where the server is listening on. In case of HTTP protocol, we know that HTTP server listens on port 80. In case of HTTPS protocol, we know that server listens on port 80, port 443. Whereas in case of client server architecture, there is no always on server. So you don't need a server that is always on and that is listening on a particular port. So we talked about how these peers actually participate in sharing a file. So arbitrary end systems directly communicate. You have the end systems that can directly communicate. In in peer-to-peer architecture, there are arbitrary random hosts that can directly communicate with each other. You don't need always on server in peer-to-peer architecture. These peers can change IP addresses, can appear and can disappear once required. So you don't need peers to be always there in the network. Peers can be there and cannot be there in the network. We will see in detail about the peer-to-peer architecture too. So one of the famous examples of peer-to-peer architectures are BitTorrent applications. All the torrent applications uses peer-to-peer architectures. VoIP application like Skype and many different other applications that are using peer-to-peer architecture. So let us try to understand in detail about client-server architecture and peer-to-peer architecture and differentiate what are the differences in these architectures by using a simple example of sharing distributing a file among different clients among different systems. So let's try to understand this architecture. In this architecture, you have one server that has a file of size f, and server needs to send this file among different clients. So this is a client which has a download rate of D1. This is a client DI, which is a peer I download capacity I. So generically, this is a peer I which has a download capacity of I. So this is a peer 1 which has a download capacity of D1. This is a peer 2 which has a download capacity of 2. This is a peer N which has a download capacity of N. So this is a server which is uploading a file. So server is upload a file that has a capacity of US. So server is uploading a traffic with a data rate of US, whereas these clients are downloading a file with a data rate of DI. So in case of client server architecture, this is the only server which is uploading a file, and these are the clients which are downloading a file from the server. So these clients are not directly communicating with each other. As in case of previous slides, we have seen that these clients actually communicate directly with each other and with the server if there is any server. So in case of peer-to-peer architecture, these clients also participate in uploading the chunks of file that they have. They already downloaded from the server. So these clients are also participating in uploading those chunks on the network so that other clients can download those chunks from them. Let's assume that again. So UI is the peer I upload capacity. So U1 is the peer 1 upload capacity. U2 is the peer 2 upload capacity. UN is the peer N upload capacity. So let's assume that this server uploaded a file, and initially only there is only one user, which is user 1. So this user downloads a file from that server. Then after some time, let's assume that this server is down for some time. So but we already know that that file is already downloaded by this peer. So these peers can download a file from this peer with its upload data rate of UI. So this peer, once appear, it start downloading a file from this peer. So after some time, let's assume that there is another peer, which is this peer appears in the network. Now this peer is downloading a file from this peer and this peer. So how they are going to manage this thing, we will see later on in this lecture, that how these peers actually transfer a small chunk of our data that they have to this peer. So ultimately this will increase the data rate, and this does not requires a server which is always on. Even if the server is down, a peer that has already that file or that data, it can participate in the network and actually seed that file. So question is, how much time to distribute a file size of F from one server to N peers? So in this example, it is shown that we are going to compute the time to distribute a file from a server to N clients using client-server architecture, in which only server uploads a file and these clients download a file, and then we actually compute the time to distribute a file using peer-to-peer architecture, in which server and the clients upload and download a file. Server is only uploading a file, the clients can upload and download a file and provide services to other peers. So peers upload and download capacity is limited, obviously. So let's talk about file distribution time using a client-server architecture. The server transmission must sequentially send upload n copies of. So in case of a client-server architecture, server is uploading, and these are the clients which are downloading. Let's assume that there are n clients. So it requires that server is uploading n copies of a file, and these are the clients which are downloading those copies. Since there are n clients, so server needs to upload n copies. So time to send one copy is F by US. Since we know that US is the upload bandwidth, upload capacity, so in order to send one copy of a file, server requires F by US time. So in order to send n copies, the server requires nf by US time. So if it is uploading the n copies, so it requires a time of nf by US. The clients, each client must download a file copy. So client is downloading a file. The client has, let's assume that these are the clients. So these clients have a different bandwidth of downloading a file. Generally, we assume that the server has more capacity, whereas client download capacity is very, very less. So let's assume that there is a download capacity, which is a dmin, which is a client download rate, minimum client download rate. These are the clients in which one of the client has a capacity which is a dmin, which is the lesser capacity of among different clients. So minimum client download time is that minimum client is also downloading a file. The minimum time that it requires to download a file. So it means that lower the bandwidth of the client, the higher time it takes to download a file. So the client that has a minimum download rate requires a longer time to download a file. So minimum client download time is a client with a minimum download rate can download a file and requires this much time, which is f, which is the size of a file, and dmin, which is the minimum download bandwidth. So in order to distribute a file in case of a client-server architecture from server to end clients using client-server approach is whichever is maximum. Either server is uploading a file and uploading the n copies of a file on the network if this is bigger, or the client which has a download, which has a minimum time, which has a minimum bandwidth to download a file. So whichever is greater actually results into the time which requires for this server to distribute a file of size f among n peers, among n clients in that network. So either this is this one or which is this one. If it looks that if number of clients are increasing, then the server takes more time to transfer a data. If the number of clients are less, then it results, this is because of this factor, and if the number of clients are more, then this is because of this number. So time to distribute a file, either this is this number or this number. It depends on if number of clients are higher, then this is because of this number, and if the number of clients are lower, then this is because of this number. So it increases linearly. Whereas in case of peer-to-peer architecture, server transmission must upload at least one copy. This server at least upload the one copy, so one copy needs to be uploaded. And now once the copy is uploaded, the clients can participate in uploading that file and distributing that file among n peers. So in order to upload at least the one copy of that file on the network, server requires a time which is f by us. US is the upload rate. Server requires, this is f file size, and this is the upload rate. So this is the time which is required for a server to upload. The clients must download a file copy. These clients are downloading a file. Again, the minimum dmin is the minimum bandwidth of a client which is downloading a file among n peers. So minimum client download time is f by dmin. We already know this thing. Whereas now this is another factor which is not there, because these clients are also uploading a file on the network. So once these clients are uploading a file, and distributing the n copies of a file, so nf by us, because server is also uploading a file, whereas the clients are also uploading a file. So as the number of clients in a network increases, as the number of clients in a network, number of peers in a network, in case of a peer-to-peer architecture increases, number of clients which are uploading a file on the network also increases. So ultimately, this is not linearly increased as in case of a peer-to-peer architecture. So this factor actually get a straight line. So as the aggregate must download nf bits, max upload rate limiting the maximum download rate is us by summation of all the clients which are downloading a file. So time to distribute a file in peer-to-peer architecture is whatever is the maximum. If this time to upload a file is greater, or this time is greater, or this time is greater. This time is larger only if the server upload rate is lower. Okay, if server upload rate is lesser, then this time is bigger. If the client minimum, the bandwidth of a client which is downloading a file which has a very less bandwidth, then it is because of this can be maximum time to distribute a file, or it can be this thing. Mostly this is not a limiting factor. Either it is this one or it is this one. So it increases linearly this time, but we know the upload time is also increasing. Upload bandwidth is also increasing. So it is not. So in case of a client server versus peer-to-peer example, client rate, upload rate is u, f by u is 1 hour, and us is 10, and d minimum is 10. Upload server upload is this time, and d minimum is greater than US. Okay? So D minimum is greater than US. So in general, you can find out that in case of a client server architecture, once the number of clients are increases, the minimum distribution time also increases linearly because of that factor, which is because of this factor. Whereas in case of client server architecture, once the number of clients are increases, number of peers are increases, this ultimately become the distribution time is ultimately become the linear, and this is because of f by u or f by d min, not because of an f by us summation of all the clients that are uploading a file. So this is the advantage of peer-to-peer architecture, and generally you have experienced this thing that while using a peer-to-peer applications, you actually download a file at a much higher rate than in case of a client-server architecture. So this is one of the example of peer-to-peer file distribution using a BitTorrent application. BitTorrent is one of the applications that is using a peer-to-peer architecture. And it divides the file into among multiple chunks. It's not always that those chunks are 256 kilobits chunk, and those can be 256, 512. It depends on how they are dividing those chunks. Peer in the torrents send or receive a file chunk. Different peers, these are the peers in case of peer-to-peer peer-to-peer architecture. These peers can share a chunk to other peers. So in peer-to-peer architecture, there is one called tracker, which tracks the peers participating in the torrent. So there is a node which is called tracker, which is tracking the nodes that is there for sharing the file, and torrents are the group of peers exchanging. So now once the client arrives, which is Alice in this scenario, it requests the tracker about the list of nodes that has the chunks of a file that this client want to download. So it requests the tracker and obtain the list of the peers from the tracker, and then actually establish a connection with those peers and start downloading the different chunks of file of specific file from different peers. So peers joining the torrent, once a peer joins the torrent, initially it has no chunk, no chunk of a file, but it will accumulate them over time from other peers. And once it starts accumulating, it registers those chunks to the tracker, and it start also uploading that chunk that it already stored to other peers. Register them on the tracker to get the list of peers, connect to the subsequent peers. While downloading, peer also upload the chunk. So it is downloading and it is uploading. They are using a methodology of tit for tat, so that each peers gets maximum benefit from the network, and that benefits are the speed of downloading speed. Peers may change peers with whom they exchange chunks. Churn is the peers may come and go. Different peers come to the network and start downloading a file, as most of you experience this thing. So while downloading, while using a BitTorrent application, once you search for a torrent and once you download a file, sometimes we actually stop uploading a file. So it says that peers are coming to join the torrent, and they leave the torrent, they leave the group. So once the peer has the entire file, they may selfishly leave, or they may stay so that they can help other different peers to download a file from there once. So BitTorrent requesting or sending a file, requesting chunks. Anytime different peers have different subset of a file, periodically Alice asks each peer for the list of the files. So once a peer arrives, different in this figure, if you look into this figure, once this Alice arrives, these different peers, it come to know from this tracker that these peers has this chunk of a file, so it's start establishing a connection with them. and then once it starts establishing a connection with them, there are some chunks of a file that are reversed in the network, and some chunks of a file that are present among most of the peers in the network. So this alias start downloading a file, downloading a chunk of a file that is reversed in the network. So alias requests the missing chunks from the peers, reverse first order. And another methodology that different peer-to-peer application using is a tit for tat. Alias sends a chunk to those peers, currently sending her chunk to the highest rate, and it actually evaluates this thing after some time, and it unchokes certain peers and start sending a data to them with this intention, which is it might possible these peers on which you just unchoke them, they start also sending a data to them. Once they start sending a data to them, actually the download rate might increase. So optimistically unchoke the peers, and it might join the top 4. So this is what I'm saying. Initially, let's say Alice unchokes the Bob. Why? With this intention in mind that it become the top 4 provider for the Bob, and so ultimately Bob also starts sending a data to Alice. So Alice become the top 4 provider of the Bob. Bob reciprocate. Bob become the Alice top 4 provider. So ultimately, this helps to increase the download rate and better quality of experience for both of them. So higher upload rate for better trading between partners and get file transfer faster.